Hello, I'm Warren Powell, and this is the Universal Modeling Framework for Sequential Decision Problems, the next generation of AI. This is part one of a five-part talk that I gave to the MIT X-Pro Leadership Program run by John Carrier. Part one is Introduction and the 7 Levels of AI. So I'm going to start with this tapestry, which roughly describes activities I've done in my career. Upper left-hand corner is trucking. I did a lot of work in trucking. Spent 10 years with Norfolk Southern developing a locomotive model. We did air cargo. For about 10 years, I ran an energy lab where we would model all types of energy systems. I worked in manufacturing, health, e-commerce. Now, all of this is from this my lab at Princeton called Castle Laboratory. And this used a unique partnership between academia and industry where we would actually write software for companies and go to implement in the field. And from the process of implementing in the field, we would learn problems that arose in the modeling, especially with the modeling of decisions and uncertainty. Now, when you take decisions uncertainty, you find virtually every human process involves decisions and uncertainty. It's just fundamental to how life works. Now, when we make decisions, we have any one of a number of goals. We maybe want to increase profits or reduce costs, but maybe we want to come up with a material with higher strength, reduce the risk of a financial portfolio, reduce the number of illnesses. Now, whenever we want to do something better, I like to say if you want to run a better supply chain or energy system or health system, pretty much anything, you have to make better decisions. And this is the defining slide of my talk. Now, as we want to use computers, inevitably we're going to run into artificial intelligence. I'm going to give a quick tour of my 7 levels of AI. Now, of these 7 levels, the first 4 are really focused on making computers behave like humans. And in computer science, having a computer be like a human is considered the highest goal. Now, levels 5 and 6 involved trying to make computers be smarter than humans. We want to outperform the human. Now, level 7, I'm going to call science fiction. We'll get back to that later. So level 1, this is what was first coming out when I started my career in the 70s and 80s. It was rule-based logic. Back then they called it expert systems. And it was the new AI, and it was supposed to take over the world. And it ended up being a complete failure in the eyes of the AI community in terms of what they were pitching. In fact, it ended up being a very useful tool that's widely used today. Now, levels 2, 3, and 4 are all a form of machine learning, but I put them at different levels because they really are quite different. So level 2 was basic statistics back in the 1900s, forecasting, estimation using linear and nonlinear models, and the early neural networks. Level 3 was pattern recognition, emerged around 2010. This was the first use of deep neural networks, 10 to 100 million parameters. And the big breakthrough here was getting a data set large enough where they could fit these networks. Now, 2020s, we went into these colossal neural networks with 10 billion to a trillion parameters, and this is sort of predicting what we might say next. Now, machine learning is itself an optimization problem. We want to come up with a function. So the function, maybe we want to estimate demand as a function of price. And the function, I might suggest a linear model. Now, somebody else might come in and say, oh, no, you can't do a linear model. You're going to have to do some sort of an S-curve. And today, invariably, somebody's going to come in and say, you have to use a neural network. Now, the choice of function is generally made by a human. Tends to be a manual process. And then generally in all of these functions, there are tunable parameters, and we use a training data set that involves observations or labels that they call Y, and they want to make the function match the training data set as closely as possible. So level 5, this is where we get to decisions. Now let's take all of my problems here. Behind every one of these problems are questions, and the questions involve making a choice. And I want to make the best choice, so these are decisions. The most basic tools are called deterministic optimization. Maybe I want to find the best path from node 2. The decision will be to go to node 5. Or maybe I'm optimizing facility locations, which is a high-dimensional problem. There's many permutations and combinations of facilities. All of this is using a language of deterministic optimization where X is one or more decision variables. Cx, we have an objective function that we're trying to minimize or maximize. And then we have a set of equations that determines what are the feasible values of X. What's the set of allowable decisions? Now, this is a language spoken around the world by people with the training, but there's thousands of students coming out of universities every year with training this language. There's standard computer packages, graduate programs with an endless flow of students. All of these books speak the same language, and it's because they all come from one book, Danzig's first book on linear programming, that really launched the field. Now, level 6. So let's go back to my tapestry and take a look at all of the problems, all of the decisions that we have to make. Now, put your eye on any one of these boxes, and this is a question. You need to make a choice, and after you make the choice, information arrives that is relevant to the choice that I didn't know when I made the choice. Let me go back and do that over again. Put your eye on a different box. Pick out a decision that you need to make. Now, take a look. This is the information that would come after you make that decision that's relevant to the decision. Now, these are sequential decision problems where you make a decision and information comes, and then you make another decision and more information comes, and so on. For example, you might have an inventory problem where you order inventory that might arrive quickly or might arrive in months, after which I observe the demands for that inventory. And then there's more decisions and more information. At Optimal Dynamics, my company, the blue circles are the drivers being assigned to loads, the red squares. Now, over time, more loads are being called in that I didn't know about when I made previous decisions that impact the results of earlier decisions. Maybe I'm testing new vaccines, and the decision is what dosage and which people to administer it to, after which I see how people respond to the dosage and which people are willing to be vaccinated. And in financial training, I have to decide what investments to invest in, after which I see changes in prices, and then I make more decisions. Now, here's a classical problem in operations management. I have a factory down in Mexico, and I have to ship to various warehouses, and I have to find the best locations for the warehouses. That is classically solved as a deterministic optimization problem, as I illustrated earlier. However, even these are sequential decision problems. I don't just solve them once, I solve them repeatedly over time. And furthermore, the decisions I make at one point in time impact the decisions I can make downstream. Now, this is what I'm going to call the most widely used, the most common decision problem. I have a set of choices. It could be a drug or a product design or a web page design, or maybe the diameter of a silicon wafer. I have a set of choices. Now, it may be that I know the choices, and sometimes I don't. What drug to use, what supplier to use for a part. These are sometimes choices where I don't know the set of choices. But let's say I have a set of choices. The next thing I don't know is I don't know how well each of them works. I have this uncertainty. And sometimes I have to do extra investigating, or sometimes I just have to try a choice to see how it does. Now, level 7, this is when we get to what we've been seeing in the newspapers. We have books by Henry Kissinger, The Age of AI, or Genesis, where they're thinking about the magical things that AI can do, or maybe AI could wipe out humanity. These discussions of AI are entertainment. I refer to them as science fiction. There is no software behind these things. You're never going to wake up and have a group of robots trying to take over the government. But it's fun. It's entertaining to talk about. So that ends part 1. I hope to see you at part 2.